MLPs are a type of neural network that are used for a variety of different tasks, such as image classification, time series forecasting, or any other sort of application. The reason they're so useful is that they are able to learn connections between data. For example, if you feed a computer an image of the number 7, how would you expect this computer to read the image of a number 7? It needs to be able to make connections between the pattern of pixels in this picture of the number 7 and the actual classification of number 7. It does this by learning a set of weights. Now, what are you even talking about with weights? Well, first of all, we have to get back to the basics. A neural network, or in this case, a multi-layer perceptron, also known as an MLP, consists of 3 basic parts: input, hidden layers, and output. The input layer is really just what you put into the network. For example, that picture of the number 7 that I was referring to before. The hidden layer is where all the magic really happens. It's what gets you from that input layer to that output layer. The output layer is the classification of the input layer, or whatever outcome you want from the neural network. For example, stock forecasting, it would predict future stock prices from your input that you trained the neural network on. The hidden layer is where all of the weights and connections are stored. For example, the hidden layer would determine that this pixel being in this location would map to this number 7 being classified. When you train a neural network, it learns a set of weights. Weights are what are learned when you multiply your input by a set of weights to get to the hidden layer, and then you multiply it by that set of new weights that has been learned throughout the training process to get to the output layer. The output layer is where the classification happens, but to get that classification, you have to use the argmax function usually. If you're doing a classification problem, there are other functions that you can use for different types of data. An MLP takes the input, multiplies by weights to get to the next layer, multiplies by weights to get to the output, then applies a function to get the information that you want out of the neural network. For example, if you were classifying this number 7, there would be millions of weights leading to the hidden layer. You'd multiply all of the pixels in this one channel image of a number 7, multiply all of the pixels by that set of weights to get to the hidden layer. Then there's a new set of weights to get to the output layer, and the output layer consists of a set of probabilities of this being each type of number. To get your actual classification, you use argmax to find the highest probability of all of this set of numbers and then classify it. For example, here, if the number 7 had a 30% chance of being the number 1 and a 70% chance of being the number 7, the argmax function would really find the number 7 is the highest. Now, it's not always this simple, but that's basically how an MLP would work. I built a multi-layer perceptron of my own using PyTorch. My MLP was used to classify low-resolution fashion items. For example, a sweater, or a handbag, or a sneaker. To start out, I defined some datasets for my training data and my testing data. My training data used the training set of the fashion MNIST dataset. My testing dataset used the testing section of the fashion MNIST dataset. I started out by showing a few examples from this dataset, like this shirt here. My actual neural network is really simple. It's just 2 linear layers with softmax at the end. This just means that there's no convolutional layers or anything complicated within this neural network. It's simply multiplying by a set of weights and learning those weights. I let my model train for 30 epochs. An epoch is when you allow the model to run through your entire dataset once. During an epoch, what happens is the data is fed through the model and it makes its prediction based on the weights that it already has. Then it determines a loss value depending on how poorly or well the model did on classifying these images. Because in the dataset the image is stored with its actual classification, the program is able to determine if it got that right or wrong, to determine a loss value. After the loss value is calculated, an optimizer is used to determine how to fix the model to achieve a better accuracy next time. 30 epochs means that it runs through all of the data 30 times and goes back and fixes it 30 times. In the end, my model got a really good accuracy. It is able to classify these fashion images correctly most of the time, which is giving computers a fashion sense. If you're interested in following along with what I'm up to, feel free to subscribe to my newsletter, connect with me on LinkedIn, follow my Medium, or check out my tks.life profile. See you next time!